Hello, Eastview Scholars, and welcome to this edition of Sharp Shorts, where what we're going to look at is what looks like a very complicated chemical reaction or processes. It's actually three processes here where ammonia, one of the most highly used chemicals in the world, mixes with oxygen, and eventually what it is it's one way to produce nitric acid down here. Okay? And I throw this out as you work on stoichiometry and we wrap things up as about the end of the challenge. And if you understand this, then you really do understand how atoms interact and mole ratios and stuff. Even though you may not think so, and you may think you're just understanding how to solve the problem, it does, if you sit back and think about it, it should help you understand how things are occurring. Now, here's what we're starting with. We're starting with 150 grams of ammonia. Okay, the molar mass of ammonia is 17 grams per mole. So the first step in any stoichiometry problem, just get it into moles, and that's 8.82 moles. Okay. Now, what I have to look for, what I want to know is how many grams am I going to end up with down here with the nitric acid. But I have to go through this multi-reaction process first along the way to build up essentially the nitrate and then attach a hydrogen to it, okay, and make the acid. The key to working between reactions is finding that intermediate, where here I have this intermediate nitrogen monoxide that is a product here and then the reactant with the oxygen here, making nitrogen dioxide, which is the product here and the reactant there. So I can't work between reactions unless I have some intermediate that is a product in the first reaction that becomes a reactant in the next step, and then maybe it makes a product that becomes a reactant anyhow. So that's it. So the key is here, this intermediate. Now, here's what I know. I made 8.82 moles. They have the same coefficient, so that's going to be 8.82 moles also. Okay? That is all when this runs out, because the oxygen, here's my excess. Okay? Here's my limiting reactant. So when all the ammonia runs out, all 8.82 moles, I will have produced, let's say we do it perfectly, 8.82 moles here. Okay. Now, since that's exactly the amount I produced, that is exactly the amount I have to start with in the second step of this reaction. Okay. That number just transfers from here to here because that's exactly how much I made. That is exactly how much I have to start with. Now, some kids will want to try and do some sort of mole ratio between the 4 and the 2, but don't. Please don't. This is one reaction. This is a completely separate reaction. How this is produced and how it reacts are two different things. Go back to what I said before. This is exactly how much I made when this ran out, because I have enough oxygen. It's floating around the atmosphere. So I used up all this 8.82 moles. They have the same coefficient, which means I made exactly 8.82 moles. And that's how much I have to start with here. And by conjunction then, since these two have the same coefficient, that's exactly the amount of moles that I will produce. Again, this is my limiting reactant. Okay. The oxygen is an excess because it's just in the atmosphere. So this is exactly the amount of moles I'll produce here, which again is exactly the amount I'll have to start with. And again, this will be my limiting reactant now. And water is an excess. I'll just be flooding this thing with water. Okay. But again, key point. Limiting reactant runs out, same coefficient, made exactly the same amount. That's the number I have to place in the next reaction because that's the exact amount I have. This is all in an enclosed container. Okay. So it's not leaking out anywhere or anything else. So this is exactly what I have when this reaction starts now. And again, because they had the same coefficient, that's the exact amount I have to start here. Now I don't have the same coefficient, so now my stoichiometry times 2/3, okay, because it's a 2 to 3 ratio, means that here I'll produce 5.88, checking my math, 5.88 moles of nitric acid, which when I multiply by the molar mass of nitric acid, 3 oxygens, a nitrogen, and a hydrogen, add up to 63 grams per mole. Which means I'm going to end up with 370 grams of HNO3. Okay? So you can see the process of stoichiometry didn't change. What you have to comprehend is that the product here, however much I have, is the exact amount I have to start as a reactant here. I make a set amount of product here, that's the exact amount I have to set there and use my intermediates. Anyhow, if you can work your way through an understanding of that, okay, and also if I said, maybe if I threw in a trick where I said, hey, this reaction only occurs at 85%, so you'd have to find 85% of that number and then put it down there. But if you can comprehend that and just sit back and understand it, you should be solid as far as all your stoichiometry steps. Anyhow, go practice and scholar up, Eastview.